Hello, and we are live. I'm so happy to start this new session of the Java Code Camp. Um, I have received so many excellent feedback from many of you who are joining for the second time in this session, and and for the new ones who are joining us for the first time. Welcome to everyone. It's my pleasure to be hosting and doing these code camps with you. We are going to be um, we are going to be learning in this occasion about refactoring, and this is not my usual setup, as you can see, because I'm not at home today. I had to travel, and but still I wanted to do the Java Code Camp, and so we're going to be doing it. I'm going to be using only one screen, so you have to bear with me at some times. But I wanted to do this, and I'm very excited about doing this session here. So as I told you before, this session is going to be all about refactoring, and we're going to be talking about different things like refactoring. How do we work with a monolith that was done a long time ago with poorly designed code, not using, I don't know, design patterns, and not using the best practices? How do we deal with those kinds of code bases? Do we how can we test this? Because if we want to refactor something but we cannot test it, how can we make sure that we haven't broken anything? This is a subject for today's episode. Actually, we're going to be talking about how do we refactor, and how do we work with a monolith that is very old. So for those of you who don't know me yet, I haven't introduced myself properly. I'm Matias Salerno. I am a subject matter expert at Globant. I've been working in Globant for more than 10 years, and we at Globant are passionate about innovation, excellence, teamwork, and building software. So today, hopefully, I will transmit that passion to you, all of you who are joining online, and you will learn also more about what we do here at Globant, but also uh, why we do things the way we do, and why are we so passionate about building software and doing it in the best way possible. So I'm going to start the presentation now, and what I'm going to be talking about is, so we have this, I don't know if we are already showing the presentation. I have my team who can confirm, but we are going to be learning about refactoring here. So when we're refactoring a monolith, having quick feedback loops is very essential. It becomes really crucial. So we need to know that we haven't broken anything, and if we don't have a good feedback loop, and when we talk about feedback loop, what we mean is we want to know that when we touch code, when we edit code, because for example, we are adding a new feature, and because we added that new feature, we are doing some sort of refactoring. We want to make sure that we haven't broken anything. And if if that feedback loop is too long, for example, if I had to wait all the way to go to production to see if I've broken anything, then it's really late. Like I cannot, I have to wait a long time to see if something is broken or not. And also, fixing an error in production is way more costly than fixing it in a development environment, because in production there is actual people using our application, and this could mean thousands or even hundreds of thousands or millions of users. So we cannot allow for these kind of errors in productions. We have to make sure that we can have a faster feedback loop. we can catch errors maybe in our local environment. That would be the optimal thing, or even in other environments like our UAT environment or our development environment, so on. But yeah, we want to have a feedback loop that is fast. And the best way to have this is by doing automated testing. And if we have automated testing, refactoring becomes really easy. So why do I do if I don't have tests in the code that I want to modify? That's the big question, because we have monoliths that don't have tests, and we had to make a decision. What do we do? And one of the things that I recommend is, first of all, we have to be pragmatic. We don't have all the time in the world to create all the tests that we want to create. So we have to take a pragmatic approach and see, okay, what's the best I can do with the time I have? Because we can go into discussions on, oh no, this is not the best kind of test and so on. But if we are on a deadline, we don't have sometimes that time for those discussions, and sometimes those take longer time. So we had to take those discussions, but we also had to take a pragmatic approach and solve the problems that we have at hand. Then the second part is we can start testing from the top down. So if we don't have any tests at all, then the best way to start testing is start from the very top of your application. So for example, if you have a web service, you could start with, or like a REST application, for example, you can start with the very top, sending REST requests, and then learning how that application behaves. And then the third suggestion that I have is we can mock dependencies so that we don't have to rely on third-party applications. So for example, if my application is calling several other applications, I need to make sure that my tests are reliable, and I cannot count on those applications to work when I'm testing. So what do I do in those cases? So basically, I try to mock those third parties, those applications that are not mine, so that I can anticipate the behavior, and I can make sure that the scenarios will always be the same, and that I won't have any connection errors and that kind of things. All right. So we have some strategies for mocking dependencies that we can use. One strategy could be to use Docker Compose. I don't know how much you know about Docker, but this is a very, very useful tool, and I use it a lot, basically. What you do with Docker is let's say your application needs to connect to a database like MySQL, and it needs also to connect to a cache like Redis, a distributed cache, and it has to connect to different, maybe Kafka, like Apache Kafka, the message broker. Maybe your application has to connect to all of that. If we do that, if we had to have all of that installed in our environment, it can be hard to install all those things, know which versions. So with Docker Compose, we can basically install all those dependencies, and we can then uninstall them very easily, because we just tear down the containers that were started by Docker, and that's it. And then the other approach, on the other extreme, we would have mocking dependencies with mock libraries. For example, you can use Mockito to mock things that, for example, classes that would access the database, like what we call in design patterns, we call it repository classes. Those classes, we can mock them, emulating the access to the database, but we're actually not accessing it. Or we could use wire mock, for example, which creates an actual mock server that that is able to receive HTTP calls. So those I would say those are two extremes of the strategies that we could have. But I could find a middle ground between these two, because the advantages of having Docker is that we can have in our local environment something very similar to what we would have in production, let's say. And with the other case, we cannot have that. So, but Docker takes more time, and it's to run tests again and again. It's harder. So, the best way in here is to find a middle ground, and we can find this middle ground with a library that is called test containers. And this library we're going to learn today in our examples. I'm looking at the messages to see if we have any questions or anything like that. That's why I'm looking at the different things that that the team is telling me. So I remember I don't have two screens now, so I need to rely on the on the messages I get on the phone. So all right, we were talking about test containers. So test containers is an open source framework for providing throwaway, lightweight, and instances of databases, message brokers, web browsers, and anything that you could run on a Docker container. So if you can run a MySQL instance in a Docker container, you can also run it in test containers. And I should say that to run test containers, to actually work with test containers, you have to have Docker installed in your laptop. So if you're going to follow along today, the different coding exercises that we're going to do, and you don't have Docker installed in your laptop, do that now. Install Docker. It will take you just a few minutes, and then you will be able to run the tests for today. But I'm counting on many of you to already be familiar with Docker, because this is this session is not an introduction to Docker. Right. So here's what we're going to do today. And I think that the team from Globant is also sharing with you guys the repository that we created for today. So this is a GitHub repository called Legacy Refactoring, and this repository contains the code for today, and it has two branches. The master branch has the solution halfway through, and the initial branch, which is the one that you have to use and the one that we are going to use today, use the initial branch to start from the scratch. So we're going to start from an existing application, a monolithic application, and we are going to be refactoring this application. So this application is called the order service. It's an application that receives a call to dispatch an order, and this order is read from the database, which is a MySQL instance, and we get the orders with their items and the different stock for all the items, and we make sure that all the items. First, we need to make sure that the order has been paid, and the second thing that we need to make sure is if the items have stock. So that's what we know about the service. So the service dispatches orders. And because we have this service that uses a database, we are going to emulate this database using test containers. So we're going to be running MySQL in a test container. Why do we do this? Why don't I use, for example, um, H2, or why don't I use, as I said before, why don't I use Mockito and that kind of things? Because this is a legacy application and it's not very well prepared for mocking in those ways. So this is like the closer I will get to a real environment that can be automated. In a Spring Boot application, for example, you can use H2 to emulate the database in memory, and that would be awesome. Like, this is very simple. But in legacy applications, sometimes that is not possible, because this application, for example, doesn't use Hibernate. Um, it uses JDBC to connect directly to MySQL, and it doesn't even use a standard SQL. It uses a very specific SQL for MySQL, so I couldn't use a different database. So to have it, because this is an old application, what I'll do is I'll replicate a MySQL using test containers. So this is a new way that you can use to uh, test an application that is old and that is not prepared for mocking, for example. And the other thing that we're going to do is, currently the service is reading orders from MySQL, but now we also want to read orders from a third-party orders service. So we're going to refactor this service so that it can call MySQL or the third party depending on the type of order. And this is because we're going to try to refactor this code, which you will see is quite ugly. And the reason we want to refactor it is because we want to extend it. And to extend this code, we need to refactor it, because otherwise the code would be unmanageable. All right, so let's go to the code. So if you haven't, make sure that you have cloned this repository called legacy refactor. Make sure that you have cloned it, and also make sure that you are on the initial branch, right? You have two branches. If you want to follow along, use the initial branch, because we're going to start from scratch. We're going to be looking at the code here and seeing kind of what it's trying to do, but I'm going to show you a strategy that you can use to try to understand the code without actually reading it too much in the beginning. Okay? I don't know if there are any questions regarding anything that we're going to do. If you have any questions regarding the GitHub repository, you can also ask Globant's team. They're helping me manage the comments and all, but we're going to start our browsing of the code. All right. So here's the order service. And oops, let me open it again. We have the order service here, and it has it has a connection string field. This is probably to connect to the database, and it has this method called the dispatch order, and it gets an order ID and it returns an actual order. So you can see that the code is quite messy and long, right? you have, it seems like it's trying to connect to the database. Then there is some SQL there, executing query. Then it goes, it seems like it's reading the result of the query somehow. Interesting. So it seems like this is trying to map the result of the query into an order object. So, and then we have an update here as well. So it's updating something. Okay. So let's see. Let's see if we can create a test for this. I'm going to create a test, and you can do this using, if you are on a Mac, you can use Option Enter. If you are on Windows, you can use Command and not Command, Alt Enter, and you will do this: create test. Okay. So we are going to create a test here. This is a JUnit 5 test, and so we're going to say test void test happy path, let's say. So instead of happy path, so we're going to call it differently. Let's just say test order dispatched. Okay. So we definitely will need an order service here. And I'm going to initialize it here. So order service equals new order service. So this receives, remember, it receives a connection string. So I need to send an actual connection string for a MySQL. But I don't have a MySQL. So how can I run a MySQL? To do this, we're going to start using test containers. So let's let me see how we can create this. So we're going to say private MySQL container. Actually, I do have how to create this, so I'm going to copy it from here. We'll put it here, and you'll see. I'm going to put this code here right now. So this code here is a new method that I created, and this basically creates a MySQL Docker container for my test. And the very cool thing about this is that this is going to be this MySQL is going to start automatically when I run the test, and then it's going to be tiered down. So whenever I run the test, the MySQL will start. You can run the test on the database, and then finally it will tear down. So there will be no side effects of the test. Every test will have a clean database. So let me show you how this works. We have this field here it will have this annotation called container, and this is, if you can see, this is a test containers. This is a test containers annotation, right? So this annotation tells test containers that we are going to start this at the beginning of the test. And then this code here creates a MySQL container, and here we're telling it what version of MySQL we want. You see, we're using Docker image name, which is how we call Docker images. They have a tag, and then they have the version, and then we have this with database name, and it says shop. So this is the name of the database that I want to use. And finally, we also are going to send to this database a this part here. And I want you to take a look at this. And if you want to follow along, just copy it from my. Let's just give you a few seconds to copy this. But this part here, mountable file for ClassPath resource, we have in our ClassPath. If you downloaded the code from the repository, in our test folder in resources, we have um, this this file called init, and this file creates the database. So it creates the actual schema of the database. So it will create one order table, it will create the items table, and it will create a middle table between the two of them. So when so orders have items, right? And items have a quantity of the order. So items have a stock, but each order has also a quantity. So for example, if I have, let's say I bought shoes, right? And I bought two pairs of the same shoes, what I will have is one order with one item, but that item will have quantity 2. If then I buy a t-shirt, let's say, then that item, the order will have another item called t-shirt, and the quantity will be only 1. So I see that we have a question saying always have a composition of instance of order service to test. Yes, so you do need the order service to test, because that's the class that we're going to test. So we will always have this here. We are going to be testing the order service. That means that we need it. We need to instantiate it. And because the order service relies on a MySQL working, we're going to also instantiate a MySQL container in the test. So back again, our example also has a few inserts. So these inserts statements will run. Okay, so you see these insert statements will, all of these will run when MySQL starts. So in our test, we're telling Docker, you're going to start the application, and this application will start with this init script. So this MySQL instance, sorry, not the application. The MySQL instance will start with this init statement. And this init statement, we're getting it in here. So these inserts will run. So we'll have a few orders to play around, right? So these orders are already paid, and there is one order in progress. So we have some examples to play around. We have some items with their stock, and then we have some order items. So items that are attached to orders. And these are orders that we want to dispatch. All right. So let's see. So now that we have our order service and we have MySQL, is that clear? I don't know if there are any other questions regarding the order service and why we're running MySQL in a container. But now that we have MySQL here, we can actually use it to get the connection string. So test containers already gives me the connection string that I need to connect to that MySQL. So remember here, how do I connect with MySQL with JDBC? Using a connection string. If we go to the order service, we'll see that in more detail. There is a method called create connection, and this create connection uses JDBC with the driver manager and all that to connect to the database using the connection string. That's very simple. So now that we have an actual connection string to a database that is running, we can also here start using our order service. So now we have an order service, we have a database running, we have tables, and these tables also have data in it. So I can call dispatch order, and I could say, for example, the order one. Let's take a look at the order one. So we have the order one should be this one, and we know the order is paid, is for customer one, and is in this created state. And also order one, let's see, we have order one. These two items belong to order one. So we should be able to dispatch this because item one has 100 stock and we only need 2. In item 2, so we should be good to dispatch this order. So what we would expect from this is something like order, and we would say something like get state, and we could do an assertion here. So assert equals, and what we are expecting here is that the state is dispatched. Okay, so we're saying assert equals, and the order should be dispatched. This is a simple test, and this would be our initial thing. So we want to test this very quickly, see what's going on. Let's see, there's another question there. It says, do we need JUnit 5 in order to run test containers? You don't, but you do need it for this example. Like if you are following this tutorial, you need to use JUnit 5. If you are, but test container supports both. It supports JUnit 4, it supports JUnit 5, so you can choose. I would recommend you to use JUnit 5 because it's the latest version. But let's say if you have a project and you don't have JUnit 5 and you have JUnit 4 or even earlier, test container does support those. So that shouldn't be a problem. And you don't have to have the container already run. The container will run when we start the test. So I don't have any containers running at the moment. If I run the test, this will run the container. So let's see what happens. Let's run this test. I need to enable the annotation processing. So now we have what else? I think right. We need to make sure that the container has already started. So let me take a look see if I did something wrong here. Because the container, oh, I forgot this, sorry. We have to put this annotation as well. The test containers annotation on our test. So the test itself has to have this annotation. This one I'm adding just for logging purposes, but you don't have to add this one. But this, you definitely need this one. This one will tell test containers that this test requires new containers. So we're going to run again our test. And we have another questions in the meantime. Could you just use Mockito to create the container, etc.? No, Mockito wouldn't be good to create a container because we want an actual database. Because I cannot refactor. If you see the code here, the code of the order service, it's such a huge mess with database calling in the middle. I cannot really refactor this in order to use Mockito. I wouldn't be able to do that. So I would need to mock with Mockito. I would need to mock the database connection, for example, and that wouldn't be very good because I could mock it, and maybe while mocking it, I wouldn't be able to understand exactly what the behavior is for all this. So because this is a legacy application, instead of using Mockito, which is my preferred option, I would use Mockito if I was working with a Spring Boot application, for example. I would definitely use Mockito in that case, or H2. But in the case of this application, because it's a very old legacy application, I'm using this to emulate an exact MySQL. And there's another question there saying, if the state change of the time, how to check this is compiled or Java detect change on database. All right, so we are going to be checking if the state changes or not. So I'm going to show you that as well in the test. So let's see. So the test has already run and it has passed. So where is the result of the test? I can see it. But well, I can see here at least that the test has passed. Oh, here, run. Okay, so here we can see the test passed, and at least the status was changed to dispatched, right? And the cool thing is that this has actually called the database. So this called it an actual database that was running in a container, and then uh, it it destroyed that container after the test ended. So I can run this again, and it will still work because the database there will be a new container created, and that container will have the initial state. So that's the great thing about test containers. So take a look. I'll run this again, and you will see that the test will pass again. And we can also see in our Docker dashboard. Let's see if I can open it. It's not there. Here's the Docker dashboard. And here's the test container and here is the MySQL that was started by test container. So you can see that things are happening. And now MySQL is gone and test container is gone. You see? And my test has passed. So now we're going to be elaborating a little bit more on this test. We would like to maybe check if the database was changed as well. For example, I could say I could try to figure out, for example, if the stock changed on the items that we dispatched. So if I go to how can I do that? It will take me a little bit because I need to actually connect to the database from my test. So that's the tricky part. So I'm going to do that. and maybe we can do it from scratch. Let's see. If not, I have the code to do that because the service already connects to the database anyway. So I could copy this and that's it. But let's do it from scratch just for fun. So to create a JDBC connection, we would say this and driver manager get connection, and we need to pass the URL. So I'm going to put this URL here, and I'm going to pass it here. And we also need to pass. I think that's the only thing we need, right? And the other thing that we had to do is we had to declare the JDBC driver. So I'm going to call here, and I'm going to. I just want to copy the name of the class. So if I go to the order service, and here, here we have to do this thing. We had to declare the driver that we're going to use, which is the MySQL driver, and this driver has already been added in your Maven POM, so you don't have to add it. But if you haven't downloaded my code, then I already have the driver for MySQL in the project, right? So we declare the driver, then we connect to the database, and this throws an exception. So I'm going to put the exception in the method signature, or actually let's just catch the exception with a try. So we're going to say try, and this is called try with resources. And then catch. In here, I also need to send the username and the password of the database. And in here, we're going to put SQL exception and just fail. So if there is an exception, just fail. So now we need to connect. So we need to create a statement. And this statement we are going to use to query the database, to query the items. So we would say, for example, and actually I think I have the query that I need to use here in my test already. So here's the query that we're going to use. So I'm going to copy it from here. So you see we are doing the create statement, and then we execute this query. Select star from item where ID is, and we want the item 1. So the item 1, if we look at here, item 1 has 100. So we want to see if item 1, let's see, here we have item 1, we will only be taking 2 of the item 1. So we want to check that we actually subtracted 2 from that stock. So how do we do that? We do next, and then we do result set dot get int, and the column name is, what is the name of the column? This is quantity, and this is okay. So we could assert this. No, this is not quantity, sorry, this is stock. The column name stock, because I was looking at the wrong table. This is the table. So we actually need to assert that the stock is now 98. and this is the stock. I'll just rename it to actual stock. There is a question there saying, this work usually do developer team or QA team? So I would say that this could be a combined effort between the QA team and the development team. But I do it a lot. I am a developer. I am not a QA person, but I do these kind of things because I think this is the best way for me to understand what's going on in this application. Because again, I would rather do this than actually go through all this code at the moment without really understanding the logic. You know. But yeah, I think it could be a combined effort. But again, we don't have to be afraid of testing. We developers, we need to embrace testing. We need to do testing. We need to do unit testing. We need to do integration testing. And test container is a great tool for integration testing. But it's a good question.
Yes, Matty.
All right. So we are going to run the test again, and crossing fingers. Let's see how it goes. It takes a while because it has to start a database, right? So it's normal for it to take a while. But this is the worst case scenario. I mean, we only have this. So it didn't decrease the actual stock. That's weird. Why wouldn't it? So we got this stock from the right item. We took item 1, which should be order 1. We were using order 1, right, in our example. Were we using order 1? We have order service. Oh, I didn't call dispatch order. That's why. I need to dispatch the order first. Then I'll put this here. That's why it didn't work. I didn't dispatch the order. And this can be refactored, right, guys? I mean, this is a very rough approach because we're trying to understand what a legacy application does, and we're trying to work with it in a way that we can make sure that this refactoring won't affect it. Because now we're going to start touching things, and if we start touching things and we don't have a test, then we don't know if we did something wrong there. Excellent. So now our test passed. That means that everything's working properly. So now I could probably put this and say, I don't know, assert, or let's just put here trying to refactor our test code, but this is very rough. This is a very rough approach, and it can be improved a lot. But let's get the actual stock like this. So now there's a new question. That is a good question. We might have a participation certificate. We need to speak with the global team to see how we can do that. but that is a good idea. Um, all right, so we have created our first test, and now we're going to do to figure out what happens if, for example, I don't know, if the order is not paid yet. Test order, test dispatch order when not paid. So we have one of the orders which is not paid, this one. This is the fourth one. So we're going to go to the fourth order. So we're going to, in our order service, oh, sorry. In our order service, in our order test here, when not paid, what we're going to do is we call this, right? And we will remove the assertions. For now, let's remove all this. So now we have this, right? We have the order service. Let's remove this as well. And let's put this in here and remove it from here as well so that it doesn't bother us. So this is the, yeah. So we're getting the actual stock here. Good. So now we have this is going well. No, sorry, that is not right. I had to go back. Yeah, that's better because we need this to create the connection. Why do we use bar and not let or const? That is because well, we're working with Java, right? And in Java we don't have let or const. If we want to declare a constant, we could say final bar, but it's not. We don't have let or const in Java. Um, so now the strategy for refactoring the first is having tests. If we don't have tests, I would say don't risk your refactoring. It will be hard. Some of these legacy applications have been running for 15, 20 years. If you don't have tests and you want to refactoring, eh, sometimes you don't have another option and you'll have to do it. But the best thing you can do is try to create tests around this. And that is what we're doing. So the first part of the strategy is create the tests, and then we'll refactor it, and you'll see how we'll do it. All right. So now that we have this in place, so we were working on this scenario, right? So order 4 is not paid. So we're expecting, we don't know what we're expecting. So let's see what happens actually. Maybe there is an error. So let's see. I'm going to run this, and I'm trying to understand what the code does. So I'm going to see if it throws an error, then I know it throws an error. But this is the idea, is trying to reverse engineer this code. Version of Java that I'm using Java 11, I think, or 14. I don't remember. Let me look for that. Here. Oh, I'm using Java 21. Sorry. But this code is very basic, so it should work with any version of Java, really. All right, so it failed because it was unable to dispatch order, not yet paid. So I like this. So I'm going to put an assertion. So what I know is that this should throw an exception in this case. So I'm going to say throws, and it's a runtime exception. So I'll just keep it as a runtime exception. And so I'm expecting this to throw an exception. That's what I'm expecting. So I put this here, and then I can also put this into a variable, the actual exception, and I can assert true exception get message contains. So I want to know that the exception contains this message, so I know that I didn't break anything. So this is fine. We could do another scenario, for example. Let me see. I had already another scenario prepared for you. Yeah, what happens if the order is not found? So, for example, um, I'm going to say dispatch order when not found. So we don't have an order 5, so we're going to say that with order 5 there should be an exception. We don't know what exception is going to be, so I'm going to remove this, let it throw the exception, and then I know what to expect. And then we'll start refactoring, if that's all right with you. So how are you liking this session? Is it interesting for you? Is it I mean, I think it's pretty nice that you can, with these tools, create your own database, create your own database for your tests, even when you have a monolithic application, and you can use it to test that monolith. All right, so we have the error. So what's the problem here? Cannot invoke iterator because get orders is null. All right, so this is completely unhandled. So this is something that we would want to change. But for now, we are saying test throws, and this would be null pointer exception. So now it's throwing a null pointer exception. We want to change that, instead of having a null pointer exception, something else, because this is pretty awful. But if I would run these 3 tests now, they run and they will pass. So let's start with this small refactoring. Let's change this. This is not going to be a refactoring. This is going to be a change. Yes, it is possible to run the application with Java 17. It should be possible. All right, so let's make a change so that instead of receiving a null pointer exception, let's just receive a new exception called let's say order not found exception. Okay, and I'm going to create this class, and be careful because I want to create it in our production code, not in a test code. So I'm going to go to the source main Java, right, and extends runtime exception. So we're going to say order with ID not found. Okay, so this means that I'm going to throw this exception now instead of that null pointer exception, because that is awful. So I'm going to go to the order service now. So when do we throw that exception? So it failed around here, I believe. It said your order, you don't have, so it said that we couldn't do this because the order didn't have any items. We didn't even have any order, to be honest. Because the order was null. So maybe you'll have to bear with me, but this is a very initial thing. So I'm going to put an if here, and let's say if order, let's see, let's take a look at the error. If the order items are null, throw new order not found exception, and we'll send the order ID there, right? And so we can verify this in our test. You see, our test now is expecting order not found exception, so we should be good now. So if I run this test now, let's see what happens. Is it working? Excellent. You see, now that I have tests, I can also run all the other tests to see. Let's just run all of them to see if I didn't break anything. We'll have to wait for the test to run because we're using an actual database, but this is the only option when we have these kind of codes that are really bad, and this is better than testing in production. I can assure you that. When the live ends, are the changes going to be committed? Absolutely. Yeah, everything's going to be committed, so you'll be able to take a look at it. Right, so our first test already passed. So we know that we didn't break anything. So that's the assurance that I like when I do changes, that I'm not breaking stuff. And this is a fully integration test. So I know that this is, the chances that this was going to work properly in production are very high. Brilliant. Everything is working. Excellent, guys. So now we're going to start our refactoring. Get ready. We are going to take a look at this awful class and start looking at things that we can do. We are going to be learning a little bit more about the separation of concerns and all that in our future sessions, but I can definitely say that
I'm not sure
I'm going to stop this because it's always Siri is always trying to talk to me. So we were saying here that we're going to learn more about refactoring techniques in future sessions as well, but I can clearly see that this order service is doing logic and it's also talking to the database. So maybe I could split that, because remember, we want our order service to also call, in the case that the order is a database order, we're going to be calling the database. But if the order is not a database order, if it is a third party order, then we'll have to call a REST service on a different machine. So if we do that, and if I put here the code to call, so let's say, for example, I start adding here if order type uh, third party. So now I have to put all the code to call a REST API here, and so on, and it's going to be huge. So this will start. You see how big this method is already. So we want to separate the logic of the orders from how we get the orders. So we're going to get the orders from the database or from a different service. So what we could do here in this case is use one of the solid principles, which is a single responsibility, which is and say, okay, this is talking to the database and this is doing the logic of discounting the stocks on the items. So there's something that is not right. The actual dispatching of the order is going to be somewhere, and the talking to the database is going to be somewhere else. So let's and there is another question saying, would it be better to use prepared statement class? Yes, it would be. This is just an example, but it would be, it's not only better, but it's the actual recommendation to use it, because it already solves some issues regarding SQL injection and so on. We're using legacy code here, so this legacy code didn't take that into account. But yeah, it is the best option to use that. Okay, so let's start with few things here. First, I'm going to be moving this huge query outside, because it also makes it hard for me to read the code. So I'm going to extract it as a constant. I'm going to do Command Option C to extract it as a constant. If you're using Windows, it would be Control Alt C. And let's just name it select order with items query. Okay. So that's our first refactor. We have to start small. What else? Okay, so here we have an order, and then we have items. What is this for? And then we do if order ID is null. If order ID is null, then it means that the order ID was not updated in the first place. Right. So here, if the order is not paid, then not paid. Okay. All right. So we can probably extract this. Let's just put it in a different method saying validate order is paid. Okay. This is easier to read than the other thing that we had. And in here, we're mapping the order. So maybe we can say map result set to order. Um, Wait. No, I don't like that. So wait, well, let's see what else is happening here. So we have items here. So in this here, what we're doing is we're creating the item. So if we are creating the items, well, why do we have the item ID here? Let's just put it. Let's just put it here, and we can we can put the item in a variable. So let's just say var item. So now we have an item, and we can put this into a method saying map result set to item. And now we can use the item here and say get what? This should return. Oh, this is adding it to a list. Wait. So instead of adding it, first we're going to here we're going to remove this from here, and we're going to create an item here. So order item. Fine. Now we have order item, and we're going to add it to this list, and then we're going to use it here to get the item ID. Okay, so we don't have to have that extra variable there, which we don't need. So now maybe we can actually have this instead of a while. Why do we have a while? We have only one order. We're looking the order by ID, so it's only one. So it shouldn't be a while. It should be if and in here actually we could say we could invert this. So if we could validate that the order was there. So we could say if not result set next, then we throw this exception, and we can remove this part. So you know this part here where we were validating that the order was not found. Let's just remove it. Oops. Order not found. Let's copy this here. Let's remove it from here, and if we validate here, that's way better. We could right. Yeah. So now we have the validation here. If there is no next, then we haven't found an order. So we can remove this if. Let's just copy the other here. We remove the if, and now we have less code. So this is also called a guard clause, and it helps us stop the flow early. Sometimes it's called early return or early throws. This is used, or precondition as well. This is used to stop the flow. So now we can focus on the happy path, the case in which we have the order. So this, I think we don't need this either, because we know the order is there. So let's just remove that. And I guess we can also remove this order initialization, because we also know the order is there. and we will just say, um, we could say, let's put this below, and let's finish the creation of the order here. So we put this here. So now this whole code creates an order. So let's just put, oh, and we also have this. This is also part of the creation of the order. And this is also part of the creation of the order. So we can put it all here. So we can put everything into a single method. And I'm going to extract this. Remember, to extract a method, you would say option command M. And enable to extract method. Why not? Because of this. All right. Here. Option command M, I'm going to extract this into, oh, it's not working. Why? Hmm. Um, oh no, actually, I think this is wrong. What I need to do is not that, because we were we don't have one result. We have multiple. Sorry, this is wrong. I was wrong. We need to go back. We need to go back to the while. Let's see. Let's go back to the while. I made a mistake here. So we have the while and we have everything here. So what we want to do is create the order. So to create the order, we need all the items as well. So I'm going to move this after the creation of the order, the actual validation of the order. And now I guess we can do this. And we can put this in here. And we have the order and the order item. So what else do we need to do here? We need to no. Let's put the order here. All right. So you see how messy this code is, right? Everything is tangled. So how do we extract this in a proper way? How do we do this? I think the problem here is that we have these items. This is used. Why do we use it? What do we have this map for? This map is used here to get the items from the order. Oh, I see. Because we don't have the item inside the order. We have only the item ID. Let's refactor the item then, the order item, to have the actual item here. So we have item. Now we can do this. Now what we'll do, we don't need this anymore because we'll just say order item get item. And if we do this, we can get rid of this map. And that is a good thing. So now we got rid of that map. And in here we need an actual item, so we're going to say new item, and this is the item ID is going to be that, and then the result set get int, and we're going to move this, the stock part, in here. So now we have the item stock there as well. Let's close this. So now we have an actual item inside the order item. And we can get rid of this map completely. We validate that the order is good in here. And then I guess we can put the so now this order item, yeah, this is good. So now we can put the order creation as a single method. So now I can extract it, I guess. Let's see. It's not able to extract it. Why? Why is it not able? Let's see. No, not like that. I want to be able to return the order. So I'm going to have to do it. I guess I'm going to have to do it the old way. I'll have to actually create a method here. Private create order map result set to order result set, and I'm going to say I'm going to move this inside that result set. Let's see. And then I can do return order. Now I can use this method result set. So you see how we're making this method shorter. And what is my objective here? Once I separate everything that has to do with the database, I can move it into a different class. That's why we're doing this. Sorry, I forgot to see if there were any questions. For cases where we want to compare object to null, is optional class a fitted option? It's not the most recommended way to use optional. So you should use optional when you are returning something that could be null. That's when you should use optional. So if you when you're saying you want to compare something that is null, if whatever you're returning could be null, if you're creating a method that could return null, then use optional instead of null, and that would give you good advantages. Instead of using instead of comparing for null, you can use optional. And actually, we talked a lot about how to use optional in the first session of our code camp. So I invite all of you who are watching now, if you want to learn more about optional and stream, look at the first session of the Java code camp where we talked about functional programming, and you will absolutely love it. Right. So now that we have it more, we're getting there in separating the database stuff from the actual method. We could also put this here and say this could be part of the database as well. So we could say this is part of the data. So you see now everything above this is all database stuff. This is actual logic because we're validating. So this is logic, this is business logic. We're validating that the order is not paid. So this is this is not something that we want to move to a database class. Here we have database stuff as well. So let's just say this is an update items template. Okay, and now this is irrelevant because we have a constant here, so we can replace it here. Now we have inline this variable here. Okay, so what are we doing here? We're going through the order items and we are subtracting the quantity from the stock. So instead of doing it in this way, we should, and then doing the database formatting, we should do all this, and this should be in the database class. So let's just move it. Instead of moving it here, I'm going to, how can we do this? We can, right, so we could, oh, I know what we can do. We could go through all the items that we have updated, and we can use functional programming. So we have order, get order items, stream, and we can um, do a map. We can map this. So we'll map every order item like this. So this is order item dot get item, and this is order item get ID, and then for each sorry, this is should be order item. No, sorry, update statement, and we're going to add it. We're going to add the update statement to our update to our state to our connection statement. So update statement dot add batch. So now we're adding update statements to our let's just put this into a method, and this would be add update add to update batch, and we're going to handle this exception. For now, we're just going to throw a runtime exception, but this is because we need to keep moving in our refactoring, because we can always refactor it even better. Okay, so we have done a lot of changes. We should probably see if we have see if everything keeps running, right? We could also put this into a constant. Update order state. So now that we have done all this refactoring, we could probably run our tests. We have errors somewhere. Enable the process order, get item, get ID. We have some other errors somewhere. Oh, because we're using we were I didn't send the connection here. No, it's because this should throw. I forgot to declare this should throw a SQL exception. That's why. That's it. Right. So I'm really scared of running the tests, but let's just try it. Let's see if we have any questions or anything. No more questions so far. It seems like the tests are working. And I was really scared. So it's working. Everything is working. You see? I did a lot of code changes and a code that it was very messy even for me, and I was able to pull it through. And I'm glad that I had those tests because now I know everything is working just fine. So my last move here, and this is to finish today's episode, is going to be I'm going to move this into a different class and run the test again, and we will wrap up. Let me go here, and I'm going to say, let's just call it JD order repository, and I'm going to start moving everything that has to do with database there. So this is going to be a wild ride. There we go. Adding the constructor parameter for the connection string. And I'm going to have here order repository. Here. I'm going to send the order repository here. So now I'm going to move this into the order repository as well. And I'm going to move going to separate this here into I'm going to move this here. We're going to say or public order find by ID, long order ID. And I need to move this part as well. Here. Remove that. And let's put this catch. Let's put this catch here in the order repository. Okay. So now if I go to the order service, I can just say order repository dot find by ID. Right, I am noticing that we are running out of time, but I want to show you how this would end up looking. So I want to show you the finished version that I already have in the master branch. So you can look at this. But if you go here in the master branch, what you will notice, look at the dispatch order method. Look how pretty it is. Find order by ID, validate the order, and you see, we get the we operate with the orders, we set the state, and then we update the order state. This is brilliant. And if you look at the orders test, everything is running. So the refactor worked excellently. But yeah, unfortunately, we were running out of time, so I wasn't able to completely show you the full refactor. But I want you to know that this is already available for you to look at. So you can look at the initial state and the final state in the master branch, and you will be able to compare the two of them, to run the test with test containers, and see that this tool, test containers, is really amazing for refactoring. So now this is how the repository ended looking. We have the JDBC order repository. So now I have an interface, and this order repository, I can create another interface, another implementation of this interface that could be the REST order repository, for example. And I can query a REST API. So this is really all for today. I want you to take this as a learning that we can refactor legacy code. It takes time. You see how much time it takes for someone like me. But it's a good exercise. You learn a lot, and you have very good tools like test containers that will help you make sure that you're not breaking anything. So that's really all I have for today, guys. I want to thank everyone for watching, and you have there the QR code for the next session, so you'll be able to connect in the next session. Remember to leave feedback. We appreciate the feedback. We like doing this, and we want to keep improving in doing these videos. And you can tell at least that we are passionate about what we do, and yeah, we want to give you the best. So every feedback is appreciated. I'll be waiting for all of you next week for the second session, where we're going to be talking more about how we can work and refactor things when we not need to introduce new features using separation of concerns and solid principles. So thank you for watching, and I'll be seeing you next week. Bye.